All right, hello, my name is Jesse Blankenship and I'll be presenting the HFSR system. So distracted driving is a leading cause of traffic-related fatalities year over year, with 3,300 deaths in the year 2023 alone. There are existing industry solutions that mainly monitor for fatigue and not necessarily other distracted driving behaviors such as texting, drinking, talking on the phone, etc. So the three key technical challenges that I ran into were dataset representation, driver action differentiation, camera positioning. In a lot of the data sets, the lighting, car interior, camera angles were not very different picture to picture and class to class. So in a real world implementation where these things can change quite a bit, the inferences started to fall back on more basic patterns like hand placement and head placement in the frame, which would often lead to incorrect inferences like false positives for different classes. So previous works used MobileNet v2, VGG16, ResNet, and a custom ensemble CNN, with MobileNet v2 achieving a top one accuracy of almost 95%, and the custom ensemble CNN achieving an F1 score of 68%. It's important to note that neither of these studies included information about the model performance on real world data and were on test data that was quite similar to the training data. My proposed solution to this distracted driving problem is the haptic feedback for safer roadways (HFSR) system. This employs motorized haptic feedback to discourage the driver from distracted driving behavior when it predicts it or sees it. Haptic feedback was chosen instead of a siren or alarm or something visual to really not add cognitive load to the driver. So this model is trained on the distracted driving dataset from State Farm. This has one class that is safe driving and 9 others, which are different types of distracted driving. This dataset does have some challenges, being that really lack of variety of the scenes aside from the driver actions, and the training image set is rather small at 22,424 images. So here are some kind of initial training performance metrics of the HFSR model. So the HFSR model does have a base of MobileNet v2. I added a global average pooling, dense dropout, and a final dense classification layer. And the confusion matrix shows that this model performed fairly well on with the training data, not confusing too many classes, really only like drinking and hair and makeup being the top false positives. So on the left you'll see images I took on an iPhone and the predictions from those. This was before the Raspberry Pi setup was complete. And you can see that there's a fairly good inference here with really just that kind of hair and makeup and drinking confusion matrix output showing up here in the middle 2 images on the left side. On the right side, this is the State Farm data set, the test data set, and the predictions for that, and these are all accurate with fairly high confidence metrics. So here are some frames from the Raspberry Pi camera module 3 with Raspberry 5 single board computer I used. You can see that it's accurately detecting right and left texting. I did notice that all actions with this that were further away from the camera on the left side were of generally lower confidence. This shows the same thing, but on the right, you see that it's predicting that it's a hair and makeup class. I believe this is because my head is obscured from the camera, like in those class pictures. And the impact and the future work. So this shows that distracted driving models can be deployed on an embedded system, and that there are currently a fair amount of limitations for the existing data sets. Really, mostly variety needs to be added. Um, Going forward, I'd like to explore more compression, see if I can fit this fully on the ARPi5 cache for locality, and to speed up inference. And if I were to continue to use the state farm distracted driving data set, I would want to augment it with some real world images with varied lighting, camera fields of view, and other variants. And this was a presentation on the HFSR system. Thank you for your time.